In this video, I want to talk about the idea of place value. The idea of place value, the quantity that a digit represents depends on the position of the digit in the number. So if I consider a number like 14, what this means is we have 110, since that's to the left, and 41, since the 4 is on the right of this number. And when children are learning to count, they can count to 14, but they don't fully understand the importance of the 110 and the 4 ones. They don't realize the importance of this, that this is a 110 and 4 ones. So they need to have this pointed out. There's lots of ways to do this. A lot of times we use things like 10 frames. So here I have two 10 frames. To do 14, we would need to point out that we would need to color in 1 completely to represent the fact that we have 110, and then 4 on the next one to represent the fact that we have 4 ones. So this is an idea that children do need to have pointed out to them. There are two ways that children extend their thinking about the base 10 system. The first is to view a group of 10 as a unit in its own right, to start realizing that we want to actually group things into groups of 10. The second is to understand that a number like 43 means 4 10s and 3 1s. And we can do this by bundling objects or with simple drawings like I have here. Here I have 4 groups of 10 and then 3 extras, so this would represent 43. And we can continue this to the idea of 100. We would bundle up 10 of these groups of 10. 1,000, we would bundle up 10 of the groups of 100, etc. When we think of it like this, each unit can be made from grouping 10 of the previously made units. And when we write our numbers, increasingly large units are represented in successive places to the left. So we write the largest unit to the left down to the smallest unit. Here I have my ones unit represented by 1 square. The tens unit would then be 10 of those. The hundreds unit is 10 of the tens. The thousands would be 10 of the 100 blocks, etc. And like I said, larger units are further to the left. And not only that, the value of each place in a number is 10 times the value of the place to its immediate right. So 100 is 10 times 10. 10 is 10 times 1, etc. Let's consider the number 1, 2, 3. There are a few different ways we can expand this. We could think of it as 100 plus 20 plus 3, since there's a 1 in the 100's place, the 2 in the 10's place, and the 3 in the 1's place. We could expand it as 100 plus 2 10's plus 3 1's. Or 1 times 100, since there's a 1 in the 100's place, 2 times 10, since there's a 2 in the 10's place, plus 3 times 1, since there's a 3 in the 1's place. If we want to draw this in a diagram, we would have 1 100 block, 2 10's blocks, and 3 1's blocks. And while this is a great way to visualize it, this can get really out of hand, especially when we want to deal with things like thousands, 10,000s, or even 100,000s. This idea of the base 10 system is highly efficient and practical. It's a great way to write numbers, and it allows us to extend numbers out indefinitely without having an infinite number of symbols to represent different numbers. However, children will have difficulty learning what written numbers represent because this idea of place values. As they're writing these numbers, they must keep the ideas of place values in mind. When they want to write something like 24, they need to remember that the 2 comes first because there are 2 10s, and then the 4 since there are 4 1s. And even interpreting written numbers requires a certain level of abstract thinking. So this is something that kids will need to be taught, and it needs to be emphasized regularly. The fact that what the base 10 system represents, and the idea of place value, the idea that a number like 14 means you have a 10 and then 4 extras.